Hello everybody. In this video we're going to talk about decibels, or actually dBms, decibels and dBms. So let's start. A dB, well, let's start. A dB is by definition is equal to 10 times the log of a ratio of two powers, P prime over P. And remember now, this is a ratio. This is a ratio expressed in dB. So here we go. This is a ratio. Now let's talk about it. And let me say this is by definition. And I recommend that you commit this formula to memory. Almost all radio engineers will use this almost every day in their life, and that's something that you just want to kind of know. Now the next term I want to talk about is a dBm, or a decibel related to 1 milliwatt. And again, by definition, a dBm is equal to 10 times the log of some power that you want to express over 1 milliwatt, and this is a dBm. Now, why would you ever want to use dBs and dBms? Well, let me give you an example of how we use it. Let's say we have an amplifier. So we start out, we have a signal over here that drives an amplifier. And the gain of this amplifier is 2. And remember, the gain is defined as power out over power in, and it drives into a load. Let's also assume that we got 1 watt going in here. If it has a gain of 2, then we're going to deliver 2 watts to the load. All right, now let's go figure out its gain in dB. So we just plug in the numbers. So its gain in dB is equal to 10 times the log of the power out 2 over the power in 1. If you do the arithmetic, this turns out to be 3 dB. All right, so sort of reviewing again, a dB is just a ratio, a measurement. All right, and we can describe things, the gain of things, how much it gains or loses, by this formula. This fraction can be bigger than 1 or less than 1. So now let me switch to a spreadsheet to kind of help depict and give some examples. All right, so and I want to show you something, a little trick. It turns out that if we do the math, that 1 watt turns out to be 30 dBm. Now notice if I go from 1 watt to 2 watts, it goes up by 3 dB. If I double it again, go from 2 watts to 4 watts, it now goes up by 3 dB. So let's go back to this number. If I'm sitting over here at 1 watt and I go to 10 watts, it jumps by a factor of 10. So as radio engineers, my recommendation is that you remember this number. Is that 1 watt equals 30 dBm. And if you double it, you add 3. If you multiply it, if you increase it by a factor of 10, it goes up by 10. Also, dBs can go down. So if you're sitting out here at 1 watt and you have some attenuation by a factor of 10 and you end up with 100 milliwatts, you now have it drops off by a factor of 10. Also, I've snuck in another term over here, a dBW. A dBW is a dB reference to 1 watt. And notice the difference between these numbers is a factor of 30. So if you had 30 dBm, you all have 0 dBWs. Again, if you were to have 10 watts, you would have 10 dBW. Some engineers, especially terrestrial guys, started life in the terrestrial world, use dBMs. The satellite guys tend to use dBWs. You can see that I started out with dBMs, which dates me, means they didn't have satellites when I was in school.